So today we discuss a new topic, capacitance and capacitor. Okay, the important topic is capacitance and capacitor. And capacitor. Okay, so here we're starting the discussion of capacitance and what is the capacitor. We consider that a surface. Take a new page. Discuss a new page. Take a surface. A surface, okay, and this surface is the equipotential surface. Okay, the name of the plate suppose is called a plate. Okay, plate A, and this surface is the equipotential surface. The equipotential surface, okay, of a positive charge. Okay, and take another equipotential surface here. Another equipotential surface. This is also equipotential surface. Potential surface, and this surface has negative charge. Okay, so gap between two surfaces D, and the potential difference between two surfaces is called V. Okay, surface is V. Now the electric field so look like if the upper surface has positive charge and lower surface has negative charge, so electric field goes top to bottom direction. Electric field in that direction, that the electric field direction E. Okay, so the positive, okay, so that positive is the lower part of the surface, and say the negative is the upper part of the bottom surface. Okay, so bottom side here, the positive is the bottom side of upper plate, upper surface is a positive charge, and here see that, so positive actually in here. Okay, upper bottom part of side of the upper surface. Okay, and that is a negative in that. Okay, so negative is that here upper side of bottom surface. So, surface means lower surface here. Okay, clear the concept. So since so there is a charge. Okay, so if I say that is a 10 coulomb positive or 100 coulomb a positive charge in bottom side of the upper surface, and here is a minus 100 coulomb upper side of the lower plate. Okay, so bottom side of the upper surface is 100 coulomb, so and lower surface. Okay, so see the carefully that upper surface has contain 100 coulomb positive charge. Actually, below that upper surface, okay, and that bottom below the, okay, and the upper part of the bottom surface, the lower surface is 100 or minus 100 coulomb. So see that their magnitude are same, but they are in opposite polarity. Okay, so these two equipotential surface have same charge quantity. Okay, so that is 100 coulomb, lower be 100 coulomb, but the difference is that upper part has the positive 100 coulomb and lower part be the lower surface be the minus 100 coulomb. So that means the total charge contained, okay, that is a Q. Okay. So the absolute value. So absolute value is 100. Okay. So the absolute value of charge, of charge in any surface, upper or lower, okay, any potential surface is called Q. Suppose that a plus Q, and that is a plus Q, and that is a minus Q. So absolute value, that is a charge, is Q. Either plus or minus, but absolute value is a Q. And the potential difference between these two surfaces, and V is the potential difference, of two equipotential surface. That is a V. So the new concept we study here, that is a Q, the absolute value of charge, is directly proportional to potential difference between two plates. Okay. So Q is the potential difference between two plates and is directly proportional to potential difference of two plates. V is proportional to absolute values of charge. Okay, means that is, suppose we call plus 1 microcoulomb, the lower part be the minus 1 microcoulomb. So absolute values is the 1 microcoulomb. That's the absolute values of charge. Okay, and that's directly proportional to V. And now we remove that directly proportional to get some constant. This is called C times V. So what is the C? C is a constant, and DC is called, okay, capacitance. Okay, capacitance. Okay, so the proportional constant capacitance. Capacitance of what is a capacitor? Capacitance of capacitor. So these two plate configuration is called capacitor. These two plate configuration is called capacitor. Clear? C is the capacitor. Capacitor is the device. Okay, and the capacitance is the capacitor is C, and the C capacitance, that is equal to Q over V. Okay, and Q is the coulomb. Okay, it is the coulomb, and V is the volt. So coulomb per volt we get Farad. Okay, the name after the scientist of Michael Faraday. Is 1 Farad equal to 1 coulomb per 1 volt. And Farad is a very large unit, okay, very large values. Why? Because if I consider some, say that R or an object, the radius is R, and approx the radius of Earth is approximate value 6400 kilometer. So that potential V, that is equal to Q over 4 pi epsilon naught times R. Okay, so put the value V here. So Q equal to C times, and that charge Q over 4 pi epsilon naught R. So these two cancel. So C equal to 4 pi epsilon naught times R in, suppose that is some values of 1, charge is greater 1. Okay, So, and you know the 4 pi epsilon naught, that is equal to 1 over 9 into 10 to the power 9, and radius of earth be the 6400 kilometers, now convert into meter, and or 30. So we get 1 over 9, so 64 over 9, and you get 1 2 3 4 5, 10 to the power 5 into 10 to the power say that is minus 9. So 64 over 9 we get 7 point something, approximate value of 7.1 into 10 to the power minus 4 farad. Okay. Now, if the radius be the 6400 kilometers, so we get a arc of so, and we see that C capacitance is independent of charge. Independent of charge. So we get value of C, that is 7.1 into 10 to the minus 4 farad. So now if I take a radius some or another object of radius, suppose is called 1 centimeter. So what is the capacitance of these? That is 1 over 9 into 10 to the power 9, and 1 centimeter means convert into meter, 1 over 100. Okay, so time these. So 1 over 9 means 1 by 9. So get 0.1111 and continuation like this into 10 to the power minus 11. Okay, so if I convert this 101 approx value, we consider that 123.20 here. That's a huge value actually. If I try to calculate like this, so that is a 1.11 continuation. So if I 30 and 10 to the minus 11, so that is okay. That is a too much huge value actually. Actually, that is you get almost 111 into 10 to the power minus 14 farad. Okay, if a small subject, sorry, minus 14 farad. So if you get a, that is a very if earth have 10 to the minus 4, suppose that is equal to consideration earth is 711 10 to the power minus 6 farad. So get 711 microfarad, very small value, and that is a huge value. Okay, that is not a equal, that is a huge value. So if the radius is very small, small object has very small farad. The large object, if earth has a huge object, so but the earth only the 711 microfarad. Okay, the very small value. So that's the 1 farad. So 1 farad is a very big value, very big value. Big value. Okay, clear? Why the farad is a very big value, and how the get from capacitance, and what is a capacitor. Capacitor is a configuration of these two equipotential surface if their gap is same, and these two potential surface have they are either the same in magnitude but the charge in opposite polarity, but the absolute value of charge q, that is directly proportional to v, and that v is that v. Okay, that is the potential difference between two plates, that is a v. Okay, now the another important concept we discuss is the charging of capacitors. Charging of capacitor. Of capacitor. How to charge capacitor? Suppose there are two equipotential surface. Okay, these two are equipotential. These are equipotential surface. This is another equipotential surface. Okay, do not confuse these two have the same equipotential. No, these have another equipotential surface. Suppose the name is called H and this surface is called L. The two equipotential surface. Okay, the potential value is different. Suppose it is a 10 volt that is called plus 10 volt, that is a minus 10 volt. And we connected these capacitor with a battery. And there is a switch, the battery, and the potential these two is a VB, that is a plus, that is a minus. Okay, so first, if the key or switch is open, if the switch is open, so you know that that is a VB be the 0. If switch is open, if okay, so now if the switch is closed, then circuit be the complete. Is K be the open, so that is open circuit, and the K is closed, that is a closed circuit. CKT is the short form of circuit. Okay, so if that B the battery voltage, okay, if that battery voltage B equal to 0, if battery voltage with a 0, so VB that's also a 0 volt. Now if B be the maximum, so maximum value, so VB also get a max value, max volt. Okay, now the important is that, okay, when the circuit is closed and these plates, see the very carefully, draw a new page, draw this plate here, that is H plate, that is L plate. Okay, and okay, so the positive terminal connected to the H. Okay, so positive here. Why this have positive? Because there loss of electron, and the electron goes in that direction. Okay, the electron in that direction. If electron be the loss, so get a positive charge here. Okay, and same concept is that the more negative in here in that direction. So more negative, computer circuit is like that, is more electron here, negative. Okay, so that is the VB, the potential, that the VB, the terminal potential VB. And here see that in the H plate have contain a positive charge and L plate contain a negative charge. Okay, but they are the magnitude of charges are the same. Okay, that okay, that means that the absolute value be the same. You have 10 plus 10, that is a minus 10 coulomb. Now this plate create an electric field in that direction. Create an electric field. Okay, and we know that V that is equal to E, and if I say the gap between these two is called L, or say that D, and a E times D, we get a potential, and that potential difference is here. That's the potential difference, B. Okay, it's called a VC. If I say this is called a VC, voltage across capacitor or potential across capacitor. Okay, when I get a more battery voltage is increased, so VC also increase. Okay, if these are more increase, VC also increase. So one time, so the VC that is equal to VC that is equal to VB. Like that, if that is a 12 volt battery, if I increase the battery voltage, so VC also increase. And certain time, If the more charge here positive and more negative has the more potential here. So that is means that if electron goes in that direction by minus, so that is a VB equal to VC. Gets minus in that direction. Okay, so one time that the maximum when VB is the maximum means that is equal to VC. That maximum VC is the maximum charging. Okay, the maximum value of charge. So VC is the maximum value of charge. Okay, means a capacitor have full charge. Means capacitor okay full charge. Means if I VB is not values are increasing here, so that's why VC is a fixed value. Okay, so that's why the VC is the maximum value. Now if I key now be the open. Okay, key be the open. Okay, now if key be the open, the interesting thing that now capacitor have the VC charge, if that is a 12 volt, now the capacitor have 12 volt. Now capacitor as a 12 volt and these are now the maximum value, then immediately not decreasing. Okay, so immediately is not a decreasing. So there is a need some if that is a positive, that is a negative. This capacitor itself behave as a source now. The positive terminal and negative terminal. I need some this capacitor. Suppose we connected this capacitor to a load, a bulb. Now the circuit is open. Kind of bulb just open, and you see that connected just here. We see that bulb is glow now. Now capacitor be discharging. So capacitor charging via battery, external battery source. Now discharging. Now after charging, capacitor behave as a source. Okay, source. And now capacitor now power supply to that battery or load, and battery with the glow. Okay, clear. Now this is called a discharging. Capacitor discharging via load. That's the concept of capacitor charging. Okay, of capacitor. How a capacitor with a charge. Okay. How now the next important is the maximum electric field. Okay. So VC when max, so electric field with the max, field with the maximum value. Okay. Okay. So now the calculating capacitance. How to calculate? So there is some assumption to calculating capacitance of a capacitor. Now calculating calculating capacitance. Calculating capacitance. There is taken some assumption is that first assumption, there is some assumption taken. The first assumption is that the charge a total Q on the plate. Okay, so these two plate, these are plate. There is an absolute value that is plus Q, that is a minus Q. The absolute value will be the same. Okay, the charge total Q on the plate. Next assumption, calculate electric field between them. Calculate E. If that is plus charge, this plate have plus, this plate have plus, this plate have suppose minus. So there is a electric field in that direction. And the thickness of plate, that's mean the thickness of plate is very, very small. The thickness of plate is very, very small. That's very important. Thickness of plate is very, very small. Now, calculate electric field. Third electric field, And if I say that field, this field also say that the electric field. Okay, sometimes I say the field means that is the electric field. Okay, and third assumption, number 3. Okay, how to calculate electric field? By the help of Gauss's law. Calculate E with help of Gauss's law. Okay, and number 4, if you know that E, okay, then calculate V. So what is the V? V is the potential difference, delta V, or say that is a V, the potential difference between these two plates. If you know E, if you know E, then calculate V, potential difference between two plates. Okay, and finally last assumption is calculate C. Calculate C. Very easy concept. Okay, so first take an surface of like that. So first upper equipotential surface, and that is a bottom of equipotential surface. Okay, thickness is very small. Okay, that's important, is thickness is very small. Okay, so that is the plus charge here, minus charge here. Up lower part of upper surface and top part of the bottom surface. So actually electric field in that direction. Okay, so gap between these two plates is a D. D, difference between these two plates is very important, and this plate is called H plate and name is L plate. Top plate plus plate is a H and lower plate is with a L. Same assumption is taken here. The plus plate is with the H, plate means the equipotential surface. Okay, if I say the plate means the surface, and that surface is equipotential surface, and negative L be also the plate, also the surface. This is also called equipotential surface. The similar H and L concept. Okay, now that area B means this area is to suppose that is this area, this area. Okay, clear? This area, this area means the area of lower surface. Okay, area of lower surface, that is A with the area. Okay, and this surface contain plus Q charge, this surface contain minus Q charge. Okay, now calculate Gaussian, calculate electric field with the help of Gauss's law. So first, if you want to calculate the electric field with the help of Gauss's law, then first we choose a Gaussian surface. So there with a Gaussian surface, suppose this surface, gray color line, these are called Gaussian surface. Surface. Okay, the Gaussian surface. Now, if the from Gaussian surface, so you apply here, that is phi flux, that is equal to charge over epsilon naught, permittivity of free space. The free space means the electric field in that direction, that gap. Okay, free space between gap between these two plates is called epsilon naught, free space. So epsilon naught times phi, that is equal to Q, and phi equal to integration, closed integral of E dot dA area vector times Q So area, if that is area be the A and that is dA vector, and E and dA both are in same direction, so that is a cos 0 degree. So A dot B means AB cos 0. So AB cos 0, we know that that is equal to 1. So you get epsilon naught times E and indication of dA times Q, and you get epsilon naught E A. So indication of dA be the A. If I consider the small area be the dA, we say the dA, so that is equal to Q. Okay, that's the first expression we found, that is Q equal to epsilon naught E and A times A. Now if you know the E, then calculate V, potential. How to calculate potential? Now bring charge from here to move there. Okay, from there to there. Lower plate L plate to H plate. Okay, so opposite of electric field direction. So opposite of electric field direction. So the V potential, that is a V, that is equal to final potential, means that V is the potential difference. Okay, that V means the potential difference between these two plates. Okay, so we know that. Okay, if Q equal to CV means that V is the potential difference between two plates, that is Vf minus Vi, and that is equal to, we know that, at minus I to F E dot. Now that is called a DL. Here E dot DL, integral of over line, and here the over area, integral over line, here integral over area. That is why put DL, and DL be the same line, be that same. Okay, so we get opposite direction, that's in plus. So I to F E dot, and E and DL angle between the be the same. Okay, so, or if you say that E dot D near angle between the same is 0, cos 0 with the 1, so EDL, that is a B. So we get potential, we get I to F initial to final EDL. Now we put a values of V. So if now remove that plus in outside direction, so E outside the integral, so integral of DL I to F. So we get DL means the gap between, is the first, that is a F there, that is the I to F. So this is the potential difference, that is the E times D. Okay, suppose that is a position here, that is position, that is E times D. Okay, so we get V equal to E times D. Now that is C equal to Q over V, and that is Q equal to epsilon naught EA, and the V equal to E times D. Now cancel these two, that is epsilon naught A over D, and finally get C equal to epsilon naught A over D. The capacitance, that is equal to epsilon naught, depending on permittivity of free space. So depending on C, proportionality, permittivity of free space, that is depending on free space. If the paper capacitor, either ceramic capacitor, that is depending. Okay, the gap between these two pairs, or air capacitor gap is a vacuum. Okay, and the area will that the area. Okay, area of the surface. Okay, area. If more surface means more capacity, C proportional to A. So more surface get more capacitance, and the D is the gap between these two surface. Okay, if D is very small, If D choose very small, so C is very high. So C inversely proportional to D. Clear? Okay. So we know what is the capacitance here today's class, and what is the capacitor, and how to calculate capacitance, and what is the two plate concept here, and how to two plate concept gets a from that concept we get a capacitor. Okay, a passive device. The first passive device in class 12 we get a capacitor here. Okay, and the SI unit of the capacitance is 1 farad, that is 1 coulomb per 1 volt, and that 1 farad is very big value. Why is very big value? And we check that here. Okay, if earth have gets a microfarad, is a very small, 1 centimeter is given 10 to the minus 4 farad, so that is needed 4 to 5 times of sorry, not 4 to 5 times, 1,000 times of arc when you get a 1 farad of capacitance. Okay, the capacitance. Okay, now capacitor is the device. Okay, so okay, the capacitance capacitor, the first lecture of concept of what is capacitance and what is capacitor. Next class we elaborate more detail about what is the capacitance, what is the capacitor, more detailing about how to calculate capacitance. Okay, in capacitor, 2 or 3 another concept we discuss here, or 2 or 3 method how to solve that capacitance and what is depending on that thing. So okay, so today end the class here. Thank you.